All right, this is going to be fairly easy. So let's add a method public boolean has cycle. Now here we need three sets. A set of node called all. We set it to a new hash set. Now initially we want to add all the nodes of this graph to this set. So all.add all. With this method, we can add a collection of nodes to this set. So here we pass nodes.values. We also need another set called visiting, a new hash set, and one more called visited. Now here we need to pick a node from the first set and start our traversal. If we find a cycle, we'll return true. Otherwise, we'll pick another node and start our traversal. So here we can add a while loop. While the first set is not empty, we're going to pick a node from it. It doesn't matter which node. We can pick the first node. So as you know, sets don't have a method for getting an item by index. So one way to pick an item is to convert that set to an array and then pick the first item. It's not the best way. I will show you a better way later. But let's keep things simple. So here we pick a node. We call it current. Now we need to start our depth first search from this node. So we need to implement this using a private recursive method. So private boolean has cycle. We give it a node as well as our three sets. So a set of node called all plus another set called visiting and one more called visited. Okay. Now, what should we do in this method? First, we should move this node from the first set to the second set. So we call all.remove this node and add it to the visiting set. Easy peasy. Next, we need to visit all of the neighbors of this node. So we need a for loop here. For each neighbor in adjacency list that get node, we're going to get a neighbor. Now, if you have visited this neighbor, we're going to continue. We're going to look at another neighbor. So if visited contains this neighbor, we're going to continue. Otherwise, if we have this node in the visiting set, that means there is a cycle in our graph. So if visiting contains this neighbor, then we know we have a cycle. So return true immediately. There is no need to look at the other neighbors. Otherwise, we have to recursively call this method and visit that neighbor. So we call hasCycle, give it this neighbor, as well as our three sets, all, visiting, and visited. Now this is going to return a Boolean value. Let's call it result. Now if it returns true, there's no need to visit the other neighbors of the current node. So if result is true, you want to return true immediately. Now this code is a little bit ugly. We don't really need this local variable. We can simply put this expression in our if statement. That is better. So if this neighbor has a cycle, then we're going to return true. Now, if we have visited all the neighbors, that means we haven't found a cycle in the current node. So we're done visiting this node, and we should move it from the visiting set to the visited set. So visiting.remove this node and visited.add this node. And finally, we'll return false. So this is our recursive method. Now back to our public method. So we pick a node from the first set. Now we should call our private recursive method. hasCycle, we give it the current node, as well as the three sets, all, visiting, and visited. Now here we have a compilation error because here we need a node object, but current is an instance of the object class in Java. So when we call the toArray method on a set, this will return an array of objects. If you want to return an array of node objects, then here we need to pass a new node array. We talked about this earlier in the course. Now this code is a little bit ugly. I don't quite like this. There is a better way. Let me show you. So every collection in Java has a method called iterator. And this will return an iterator object. We can use an iterator to iterate over an object. Now this iterator object has a method called next. This will return the next object that is available for being read. Now, if you're confused by this, don't worry, I'm going to cover this in detail in my upcoming Advanced Java course. But all we are doing is picking an object from our first set. You may use this approach or simply convert that set to an array and then pick the first item. This is a more efficient approach because by converting this set to an array, we have to allocate some extra space. Now, if we have 1 million items in this set, we have to allocate an array to store 1 million items. Not very efficient. So here we call this method, and once again, this is going to return a Boolean value. If it's true, we're going to return true immediately. There is no need to traverse other nodes of this graph, okay? Otherwise, if we end up here, that means there is no cycle in this graph and we return false. Now let's test our implementation. Back to the main class. I've created a simple graph with 3 nodes, A, B, and C. There is an edge from A to B, one from B to C, and one from A to C. There is no cycle in this graph, but let's verify it. So we get false, beautiful. Now, what if we change the direction of this edge from C to A? Now we have a cycle. There you go. So this is how we detect a cycle in a directed graph. In the next section, I'm going to talk about detecting cycles in undirected graphs.